This is just 3 short presentations, and I'll try to keep this to, oh, come on, to 20 seconds. I'm sorry, 20 minutes. I turned my timer on just now. So let's get started. This first one happens to follow very nicely after Kai's. David and I just wanted to go through setting up the Skywatcher with the QHY. By the way, if you can't hear me, let me know. Yesterday, people said my volume was a little low.
I hear you fine.
Okay,
it's
good.
fine.
Okay. So this is what we do in preparation to observe, in addition to all the information that Kai went through about calibrating the QHY. We have a 16-inch Skywatcher go-to on the collapsible Dobsonian. We use this as a transportable scope. It's not on a fixed mount. And we have it stored on a scope buggy to make life easy to get it in and out of the garage. The camera is, as I said earlier, the QHY 174 GPS. And we have set up the finder to be actually a RunCam Mighty Mini rather than have to try to crawl up to the top of the telescope to look through the video, the normal finder. So we have this displaying to a portable video screen or a Win 10 tablet using the IOTA video capture. And both the camera and the telescope are powered. In fact, both cameras and the telescope are powered with 2 Talent Cell 12-volt batteries. These are lithium batteries. They're very small in comparison to the usual cell battery that you use for cars. And they've worked quite well for us. And I use a Dell laptop, which actually happens to be the one I'm doing this presentation on, for SharpCap data collection. So steps in preparing to observe: we collimate the scope, we attach the camera and the finder, adjust the finder if needed to align with the scope, perform star alignment, find the target, and record the event. Sounds simple, right? First, we need to collimate. With this particular scope, we see it has to be collimated every time. Even though it's just been in the garage and hasn't been moved around too much, it still needs collimating. Also, I think others have gone through all the steps of using the collimation, so I don't need to. But you need to collimate carefully. We have learned, or I have learned, it's possible to pop the primary mirror completely out if you run the screws too close to their limits. It was a terrifying evening. This is the video finder. This is a Mighty Mini version of using the RunCam Night Eagle that has been placed in a finder holder with a cylinder built by John Moore using a 3D printer, and he will supply you with the codes to make one of your own if you request it. And this is the 2 pieces that's it assembled. So you put that on the scope and align with the scope, checking usually with whatever bright object you can find, so you try to get both of them in the field at once. And rather than adjust the finder so that the 2 centers align exactly, usually we have a much bigger field of view in the finder than we do in the scope. So we just use a piece of painter's tape on the scope field of view. It doesn't harm the screen of the display device, and it's a lot more convenient. And if it turns out that the 2 field of views don't coincide, you find that the field of view of the scope is completely outside the field of view of the finder. Usually it's an attachment problem of the finder. This attachment is not exactly, a precision item down here. And oops, I didn't mean to do that, excuse me. And sometimes it just gets in crooked and you have to pull it out and stick it in again. So this is the camera and the finder attached. And one thing I'd like to point out, I put this together in the daytime so it's more clearly visible. Look at all the wires. This is a bit of an annoying problem. This particular cable is the very, very long cable that comes with the antenna for puck for the QHY. And then there's 2 power cables, one for the RunCam, another for the cooler on the QHY, and then also the cable for the QHY to go to the capture computer, and a cable from the run cam to go to its display device, and also this black one that goes out of sight too is the controller for the run cam if you want to adjust it. So, you know, sometimes all these wires can be a bit of an issue. We've had problems with them getting loose or getting stuck in the mechanism of the telescope. This is the observing table. This is a freestanding table that goes along with all of this equipment. It holds the battery, the video display and its battery right here, the finder charts, the laptop running SharpCap, its mouse, flashlight, maybe glasses, maybe a cell phone. You have to be careful and move this with the scope when it's loose. Otherwise, you will be either pulling against the camera or knocking things off or unplugging here. That has happened. It just gets unplugged. You want to avoid stress on the cables, and so we find that it really requires two people, one to operate the scope and the other to carry the table when you're doing the alignment or finding the target. Once the target's in the field of view, then everything can be run by one person. So aligning the scope, we prefer the 2-star alignment. We check the alignment by commanding the scope to another nearby target using the position accuracy enhancement if it's close but not close enough. And here's a couple things that can go wrong. Misidentify an alignment star. Sometimes stars have other bright ones nearby and you pick the wrong one. Or you've made a mistake on entering the coordinates or the date time entry in setting up. Then finding the target. If it's a really bright object, it'll be in the scope catalog. But that doesn't happen very often, like never. So you need a finder chart, and then usually have to add the target star position as a user object to the telescope catalog. And David usually uses Google Sky to augment the finder charts. So the problems that come up here, the camera is red sensitive, so the target area that you see in the field of view isn't going to necessarily match the finder charts. The red stars will look brighter and the blue stars will look fainter than what the catalog will show. If you have the asteroid in the field of view, it can look like an unexpected star, and sometimes the asteroid is the same magnitude as the star. It can be a little confusing. And also you can find, if you're really going after a very faint object, there'll be a lot more stars in the field of view than on the finder charts. Google Sky will show them. But if you come to the point where you're pretty sure you're on the target area, but you still just don't see the target, and the event time is running close, take the data anyway. You might find it in the post-processing process. That's rather than just giving up. Okay, I see I have about 10-15 minutes left, so I'm just going to go to the next talk.